Okay guys, so let's now go over quadratic inequalities. Quadratic inequalities are section 3.4. Okay, quadratic inequality section 3.4. Okay, what is a quadratic inequality? Let me give you an example of a quadratic inequality. We have the following. We have this. A quadratic inequality is this: x squared minus x is greater than or equal to, if you want to, it doesn't matter, is greater than or equal to 6. This is a quadratic inequality. Okay. To solve quadratic inequalities, you must set one side equal to 0. Okay. To make it easy on yourself, try to keep the quadratic term positive. Okay. So we must set one side equal to 0. So I'm going to bring this 6 to the left so that the right hand side is 0. Okay. That's the way we solve quadratic inequalities. So bring it over. 6 come over. So now we have x squared minus x minus 6 is greater than or equal to 0. Okay. Now, what we want to know now is, think of this. There's a parabola. This is a parabola, and where is the parabola greater than or equal to 0? That's really the question. Okay. Now, but you don't have to know that yet. All we want to find out is where is this quadratic is greater than or equal to 0. The first thing to do is, once you have one side equal to 0, once you have one side equal to 0, then the non-zero side, on the non-zero side, factor. Try to factor. So first, x times x is x squared. Got it? Factor. 2 times 3 is 6, but we need negative 6. Because this is negative, I'm going to make the bigger one negative, so therefore this is going to be negative 3 and plus 2. And now I'm going to check. Okay. X times x is x squared, got it. 2 times negative 3 is negative 6, got it. And what is outer? This outer is negative 3x. And what is inner? This inner is positive 2x. Add them up, and you get negative x. And that's negative x, so this works. So we have factored the quadratic side, okay? So we factor the quadratic side. Now, each factor is going to produce what I call a boundary value. You see this factor? This factor is going to produce a boundary value. And this factor is going to produce a boundary value. Okay? So let me say the boundary. Did I spell it right? Boundary values. To find the boundary values, okay, the boundary values, take the first factor and set it equal to 0. X plus 2 equal to 0. And take the second factor, x minus 3 equal to 0. And solve each equation. If x plus 2 equals 0, x equals negative 2, or x equals 3. Those are the boundary values. Now, go to the number line and locate or mark your boundary values, okay? So negative 2, I'm going to say negative 2 is there. Circle negative 2. 3 is to the right, obviously. 3, circle 3. Let me get that top, okay? Oh, I just want somewhere else. Okay, so those are the boundary values, okay? Now, good class. 2 boundary values gives you 3 regions. From negative 2 to the left, that's a region. From negative 2 to 3, that's the second region. From 3 to the right, that's the third region. We're gonna check each region and we're gonna plug in, we're gonna pick a point from each region, okay? That's how we check. We're gonna pick a point, a value, not a point, but a value from each region. We're gonna plug it into this inequality, okay? This one here. If we get true, we shade the region where the value came from. If we get false, we don't shade. If the shaded region is a solution to this. Does that make sense? Okay? So let me repeat that again. To find a solution, we want to find the shaded regions. To find the shaded regions, here's what we do. To find what is the solution, here's what we do. We pick a value from each region. We plug it into the inequality that has the factors, okay? If we get true, the region where the value came from gets shaded. We shade it. If we get false, we don't shade it, okay? So let's pick a value from this region. What is a value from this region? Any value, it doesn't matter. Pick negative 3. Negative 3 is to the left of this negative 2. So negative 3 is in this region. So let's pick x equals negative 3. And let's plug it into the factored inequality. Let's plug it in. Watch how easy this is. Plug it in there and there. So what's negative 3 plus 2? Negative 3 plus 2 is negative 1. And it says times, look. What's negative 3? Negative 3 minus 3. What's negative 3 minus 3? Negative 6. And it says greater than or equal to. Now, what's a negative times a negative? Positive. Is a positive greater than or equal to 0? Yes. Yes, it is. So therefore, because we got a true statement, this is true. Because we got a true statement, we shade this region. Yeah. So therefore, this shaded region is a solution to this inequality. Okay? Go to the next region. Okay? What is a value between negative 2 and 3? 0. So try x equals 0. X equals 0. Plug it into the factored inequality, okay? What's 0 plus 2? 2. What's 0 minus 3? Minus 3. A positive times a negative is negative. Is a negative greater than 0? No, that's false. This is false. So therefore, because it's 4, you don't shade that region. Try the next one. What's a value to the right of 3? 4. So try x equals 4. X equals 4. Okay. Plug it into the factor inequality. What's 4 plus 2? 6 times. Because it says times, look, 4 plus 2 and then times. What's 4 minus 3? 1. And it's greater than or equal to, look, a positive times a positive. That's positive. Positive, right? That's 6. Is 6 greater than or equal to 0? Yes, it is. Therefore, we shade because we got true. Now, question. Is negative 2 and 3, are they shaded? The answer is yes, because we have this equal. So we shade it. So now, let's give the solution to this inequality. What's the solution? Solution. For this inequality, it's going to be from negative infinity all the way up to negative 2. Because it's closed, it's included. The negative 2 is included, so we use brackets. You never get to negative infinity. If you start walking towards negative infinity, if we start walking towards negative infinity, we're going to get old and we're going to die and we'll never get there. So that's why we can never include negative infinity. Therefore, negative infinity is always parentheses, open. Or, the U means or, from 3 up to infinity. 3 up to infinity. Is 3 included or excluded? Included, parentheses. I'm sorry, brackets. How about infinity? You'll never get there. No one is ever going to get there. So that's why it can never be included. And that's the solution to that. Now, let me show you this. Guys, this here is a parabola. This one here is a parabola. And because the leading coefficient is positive, it opens up. So we're saying that this parabola is above. This parabola is above the x-axis. From 3 to the right and negative 2 to the left. Let me show you. I'm going to call this parabola, y. Parabola. So y equals to x squared minus x minus 6. You guys remember how to find the vertex in a parabola? The x-coordinate of the vertex is negative b over twice a. Remember that? Here b is negative 1. Negative b is negative 1, right there. You see that? negative 1. Negative 1 over twice times A. What is A? 1. A is 1 right there. This is A. And C is negative 6. So A is 1. Okay. So therefore, what's a negative to the negative? 1 over 2. That's the x-coordinate of the vertex. What is the y-coordinate of the vertex? Y-coordinate of the vertex. I'll just plug this into my quadratic. Take half squared minus half minus 6. What is half squared? 1/4 minus half minus 6. What is 1/4 minus half? Come on, what's 1/4 minus half? 1/4 minus half, isn't that negative 1/4? Minus 6. Negative 1/4 minus 6, isn't that negative 6 and 1/4? This is negative 6 and 1/4, right? Multiply 4 times 6 is 24, plus 1 is 25, it's a negative 25 over 4. Watch this. So go to the x-axis and the y-axis. X and y. Okay. The vertex for this parabola is at a half. So this is 1 and this is half. And also negative 6 1/4. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. So this is negative 6 and then and 1/4. So this is half. So the x-coordinate of the vertex is half. Go half and then go down 6 1/4 right there. That's the vertex. Okay. All right. We're trying to graph the parabola. Okay. Now, the parabola crosses the y-axis when x equals 0. So plug in 0 there and 0 there. So when x is 0, y is negative 6. Right there. Okay. By symmetry, when x is 1, y is also negative 6 by symmetry. Right there. So the parabola opens up. Okay. Now look. What we're saying is this. This parabola is greater than or equal to 0. In other words, this parabola is this is y equals 0, guys. So what they're saying is the parabola is above the x-axis, which is y equals 0. Parabola is above the x-axis or equal to the x-axis, okay? So parabola is above the x-axis where? From negative 2 to the left and 3 to the right. Okay. So here's the parabola. Here's 1, 2, and 3. So parabola opens up. It passes through 3 and then up. And then negative 1 and negative 2. And so therefore it also does this. This parabola does this. And there we go. Okay. The vertex is at half, comma, and negative 25/4. That's the vertex of the parabola. Okay, so look, from 3 to the right, parabola is above or equal to 0. From -2 to the left, parabola is above or equal to 0. That's what this is saying. Okay, good class. All right. So therefore, this is section 3.4. Okay. The very first step is the important one. Okay. Let's do another one. Okay, let's do another one. Just to get you guys more practice. One more. All right? One more. All right, here we go. One more problem. Here's one. Solve each inequality, okay? And so, this one, look, here's a good one. So solve this inequality. Solve 2 plus x is greater than or equal to x squared. Okay? That's the problem. Now remember, we call this quadratic inequalities. What makes it quadratic? There's the quadratic term. And there's the inequality symbol. So this is a quadratic inequality. What's the first step? Set it equal to 0. Set one side equal to 0. So here's what I'm going to do, class. I'm going to bring this to the right and bring this to the right, and this is going to become 0. So 0 is greater than or equal to x squared minus x minus 2. Okay? Note, the quadratic is less than or equal to 0. Okay? The quadratic is less than or equal to 0. Okay? All right, no problem. Okay. If you want to rewrite this, the quadratic, x squared minus x minus 2 is less than or equal to 0. Those two are the same. They are the same. And we're asking the question, where is the parabola less than or equal to 0? Okay. First step we said was what? Factor the non-zero side. Factor. X times x, 1 times 2. This is negative, so make this plus and make this minus. You better check. X times x is x squared. 1 times negative 2 is negative 2. What's outer? Negative 2x. What's inner? X. What's negative 2x plus x? Negative x. Now, let's find the boundary values. Values. How do you find the boundary values? Set the first factor equal to 0. X plus 1 equals 0. Or set the second factor equals 0. X minus 2 equals 0. X plus 1 equals 0. X equals negative 1. X equals 2. Go to the number line, draw your number line, and then draw your boundary values. Make sure that the negative is always to the left of the other one. The smaller value, you better always write it to the left. If you don't do that, you're gonna get it incorrect. So -1, circle, and 2, circle, and do that. Now, let's plug in a value from each region. By the way, this parabola opens up. Don't forget that, okay? So, it seems to me, because this parabola opens up, the answer is going to be at the edge to the left, at the edge to the right, okay? But we're going to check anyways. Okay. So what should we plug in? Should we plug in x equals to -2? What's the value here in between? X equals to what? 0. And here x equals to what? 3. Okay, plug in easy values. Just make sure that the values come from each region. The first value, -2. Plug it into the factor side. The factor side. -2 plus 1 is -1. -2 plus 1, that's -1. Times. -2 minus 2 is -4. Less than or equal to 0. Oh, we're asking where it's less than or equal to 0. Oh, wow. Okay. So a negative times a negative is? A negative times a negative is positive. Is a positive less than or equal to 0? False. This is false. So you don't shade. You don't shade. Plug in x equals 0. 0 plus 1 is 1. 0 minus 2 is -2. Is that less than or equal to 0? True or false? True. This is true. So we shade that region. This region is shaded because we got true. So here's what's happening. I think I said it incorrectly earlier. We want to know whether parabola is less than 0. Okay? It seems to me it's going to be less than 0 in this region. Because look, it opens up. So it means the parabola is going to open up. Okay? It's going to open up. It's going to be less than 0 in this region. And then it's going to go up and it's going to be above 0 in this region. So there's going to be false here and false there. False there. Let's try this one just to make sure. Plug in 3. 3 plus 1 is 4. 3 minus 2 is 1. Is that less than or equal to 0? True or false? False. A positive is not less than or equal to 0, so that's false. Hey, okay. Okay, very good. Now, you guys go ahead and call your parabola. This is your parabola. You do this on your own, okay? This is your parabola. Graph it. Go ahead and graph it. Find the vertex. Okay? And also find the zeros. These -1 and 2 are going to be the zeros. Those two numbers, -1 and 2, is where the parabola crosses the x-axis. You go ahead and graph it, okay? All right. It's going to look like that. Okay. All right. You guys find the vertex and then graph it, okay? And so this is gonna be section 3-4. Section 3-4, good class. Section 3-4. And so therefore, this completes those two sections, okay? All right. All right, class. You guys have a nice day, okay? I will see you soon. Take care, okay? Be careful. All right, this situation that we're in is it's going to be over soon, okay? just stay away from big groups. We don't want this virus to be spread. So let's do this for not only for ourselves, but for our families, for our loved ones. Okay, let's stay away from big groups. Stay safe. Okay, and do the homework. Do the homework on 3.3 and 3.4. Okay. Take care, and I'll see you tomorrow at 2 p.m.